Hello, my dear machine learning engineers, how are this whole universe? Hope to this one, I'm a Rashman who being swallowed through my own experience, and today we're communicating with you about how to apply robust clustering algorithms to the areas of sports, to the sports industry, to the running, when you move your hands and also the legs and things of this nature, and also about different types of hockey and other fields of our sports exercises and human activity recognition things. We will talk about this. Okay, first of all, what's robust clustering? Robust clustering, it is the sub area of clustering. Clustering, it is when we group the objects into the specific clusters. For example, we have athletes that have the specific skills, they improve their legs to the nice amount. For example, we have different types of sports. Yes, we have running, we have hockey, we have football, we have soccer, we have different types of things, and actually it's different types of clusters, and they could be connected to each other a little bit kind of with special spatio, spatial intersecting each other. For example, we have athletics, we have running in sprinting. It means that 100 meters, 200 meters, 400 meters, or 800 meters, and also we have actually 100, 200, and 460 meters, and also we have running to, for example, long distance running. It is actually almost the same, but not the same. It is kind of clusters that are kind of super tight to each other, but not super tight if we'll compare it, for example, with hockey, or maybe tennis, or maybe basketball, or things of this nature. Actually, yes, running could be inside of the basketball, but running in athletics, it is a little bit another things. And to the running, in terms of the sprinting, it is kind of connected to the middle distance running, and middle distance running more connected to the long distance running. It is what I mean. It is actually different types of activities that are connected to each other if we will represent it in terms of the speed, in terms of the endurance, in terms of the muscles, biomechanics that are used in our body. Okay, and it is about clustering. Clustering, actually, it is grouping the objects that have the same meaning, the same kind of meaning in terms of the numbers. For example, we have numbers 3, 4, 3, 2, 3, 4, 5, 3, 4, 3, 2, 3, 4, 5. We have these types of numbers, the set of numbers, and also we have the set of numbers such as 1 million, 2 million, 1.3 million, 1.4 millions, and etc. Yes, we have different types of this type of the large numbers, and we have small numbers. Actually, we can group them together because they are kind of similar to each other, but it is all about how precisely we will look at them, because we can look at them in the super kind of differential, we can integrate them, or we can differentiate them in terms of that they are different to each other. Yes, and things of this nature. Okay, I need to drink water, everybody. The same with these two objects. These objects are the same, but there are difference between them. Actually, we can say that they are the same, but we can say they are different in terms of this contains water, this doesn't. And also in terms of this, if we'll compare this to this, actually they look not super similar, but a little bit similar because these bottles. And for this, it is kind of more similar to each other if we will compare with this small bottle of water. Okay, a container that we can compare to each other. Okay, right now you have kind of movements of your neural networks inside of your mind that they are actually kind of connected to each other. Okay, and also we have different types of clustering. Yes, k-means plus, k-means sharp, plus, k-means plus, dbsgana, Kurt, chameleon, clarence, fast clarence, fast PM1, fast PM2, faster PM, eager PM, DMV, CJ, DMV, SSC, DMV, CV, AE, RCC, RCDR, SGD, DRC, DEC, COR, HOM, affinity propagation, aggregation, min batch, min spectral clustering, ultra scalable spectral clustering, ultra scalable ensemble clustering, Agnes, Diana, agglomerative nesting, and also divisive analysis. It is different types of clustering that we have in our life. And okay, if we will compare different types of clustering, that we have different types of variations that we have inside of our clustering algorithms. And one of these variations, it is robust clustering. Okay, robust clustering, it is when we have the data. Yes, we have data. Imagine that we have a y-axis and x-axis, and actually we have different types of points that are on our plane of x and y. XY plane, yes, we will imagine. And also we have dots inside of it, and we have kind of connections, we have dots, yes, and we can group them. It is one. For example, you can look at the background, yes, for example, that we have a background of mine, yes, and of ours, yes, and it is our thing, yes, it is the door kind of our, I don't know what it is, kind of closet, or not a close, small thing, the container that we have inside of it, something. And we can say that it is kind of one color, it is another color, yes, and it is 1, 2, 3, 4, 5, 6, and different types of them. And also we have this one, it is one another different, and actually it is kind of clustering of these things, yes, it's kind of dots. If we will imagine that dots are super mega kind of connected to each other, that between of them there are super small amount of centimeters, inches, and things of this nature. Okay, you kind of can say about it. And also the robust clustering, it is when we have data, yes, imagine, and we have some data. Imagine that here's the one group of data, here's the second, here's the third, and here's some dots, 2 dots, for example, that are super not similar to this kind of 3 clusters. And robust clustering, it is about removing these types of 2 dots that are kind of super mega unsimilar, the dissimilarity of it we have to this main sets, we kind of delete it, remove it, or maybe we can decrease the influence of these 2 dots, and then, or we can increase the influence of these 3 main clusters, and we can kind of not notice it in terms of kind of it's blacklisted, yes, for example, or maybe it is ignored, or different types of words that we can define synonyms in terms of the delete, remove, eliminate, and not notice, and etc. Okay, and actually we are noticing only what we need, and it is all about robust clustering. And robust clustering could be used in different areas of our sports industry. And we will talk today about the sports industry of running, of athletics, and maybe about something else if we need to do this. Actually, in terms of the robust clustering, in terms of the running, we have the people, yes, we have different types of devices, for example, that could measure our kind of body properties, body parameters that we have during the run, during the movements, during the biomechanics of our running, yes, of training, and etc. And we can run actually, and we have body movements inside of us. It's fine, it's okay. And we have data out of it. Human, it is the task of human activity recognition. Human activity HAR, yes, HAR, human activity recognition, humano actividad recognition, everybody. And we have this data of running, yes, they are running amazingly, kind of singing songs, and etc. And we have kind of the most repeated things during the run. For example, you run the same roads, yes, okay, fine. You run by using the same clothes, okay, fine. You run with the specific biomechanics that you are majorly do, fine, okay. And sometimes you do different types of roads, different types of clothes, different types of movements, different types of human activities in terms of the running. And okay, we have one cluster, another cluster, third cluster, fourth cluster. And sometimes some super kind of rare super events that are super exaggerated in terms of the low numbers, for example, if we will talk about it in terms of the numbers, because all the data, all the points, it is the numbers in terms of the x and y, everything's fine. Wow, it's a rhyme, everybody, yes, and one more, let's go. We have different types of points, yes, and exaggerated points. We have points that are kind of super big in terms of the x, it will be directed in this direction, and also y will be here's the origin, and it goes to the right, it goes to the upper, to the above, everybody. And here's the dots of exaggerated maximum, yes, and here kind of, yes, it's our quotation, and here is exaggerated minimum, yes, for example. And we have the clusters that are appeared here. It is kind of normal situations that we have, kind of statistics things. And if we'll try to find aggregation functions out of this main cluster, aggregation clusters, it could be mean number, finding the centroids, finding the midoids, finding the different types of the aggregation function. Aggregation function is actually when we take the big amount of numbers or the specific amount of numbers and make it as one. It is kind of stay as one for the alliance, for the horde. It is kind of from the World of Warcraft, from this computer game. Okay, and make it as one, aggregate it in one, make it kind of consolidate in one, aggregation function. Okay, and we will count, for example, the centers of these clusters in terms of the robust algorithms to find the centers of these clusters. And when we look at this, it is the small point that is super exaggerated, and it is on the lowest and it is on the highest, and they could kind of they could corrupt, they could kind of make our data, make our aggregation functions not correct, kind of a little bit changed. It could be kind of a little bit interpreted not correctly fully. I imagine that you have here's the kind of the circle. We should have here's the dot, and I mentioned that you have here the dot, and when we can calculate from the data, I mentioned here's the center, here's the main points, and here's 1 or 2, 3 points of that we don't need, and actually we calculate from all this data the mean number, average number, arithmetic mean, and then it will be the center will be kind of there, but actually center should be here, and that's why we use robust clustering, and we will eliminate or decrease the influence or increase the influence of our main things, and we will not notice this go out, go away, you are not we are not happy with you here, we are not funny with you, okay? Or maybe we will be funny if we will think about this as one more cluster, yes? And it's about kind of about clustering, but not noticing specific clusters that are not super kind of nice, that we think that it is not super valuable data, okay? In terms of this, valuability of this data not super high as we want to have it. For example, valuability in terms of the you want to measure the person's height, yes, the person's what's height of this person, and you have the data, for example, what music he's listening. It is the data kind of valuable because sometimes we have correlation between the music and the height of the person, but it's not super connected to each other. If we will have for example, the weight of the person, it will be more connected, yes? Or if we will have the sizes of arms and sizes of legs, then we have the opportunity to predict the size of the person more. It is more valuable data if we will compare with with these types of data, because music that person listens, it is not super correlated with it. Okay, it will be far away. Also, we have the information about the, for example, what I said about the weight. Yes, weight is nice too, but sometimes people could be obese or maybe could be super underweighted. Okay, and also we have the data of the nice data. It is anthropometric metrics of the body in terms of the sum of the body, and we can predict by using the sizes of our arms and sizes of our legs. We can predict, or sometimes even calculate, if we have all the measures, kind of need to sum this, and okay, everything's fine, we found it. And correlation between it is amazing. Here is we could delete it, is so we can kind of consider sometimes, and this data we will use. So valuability, we have value value, yes, of the data. Actually, this is what we have in our life. And thanks a lot for watching this video. Actually, yes, we can say thank you a lot for watching this video, but actually about the movements in terms of the sports, what type of data we will use in terms of the kind of if we will talk about running, what type of data? We have human activity recognition, for example. We have they are running, they are moving, sometimes they could fall. Yes, it is a rare event, but if it repeats a lot, then it will be not a rare event, we will consider it. If we fall not so much, then we will not consider. It is all about the kind of philosophical question, what we will consider and what we will not. It is about this question, yes. And also about running, we could use steeplechase, I forgot, hurdles, yes. We can jump through the specific hurdles, obstacles, yes. And it is one of the things. Also we have race walking when you move your legs, and kind of you have the kind of activity. And the rare event, actually it should be considered, I guess, because sometimes when you do race walking, yes, you have the movements of your legs, and your legs are connected to the ground, and in terms of the, it should not be, your legs should be always connected to the ground. But sometimes we have 50 milliseconds to be 40 to 50 milliseconds to be in the air position that we are flying, but it is only 50 milliseconds, not more. Actually, kind of it will be better than less than this number. And actually it is about how juries will say, yes, it is are you flying or not, are you running or not, because race walking, it is you don't need to run, you need to race walk, you need to walk, and kind of these things. Okay, it is about this. Also we have in athletics jumping, long jumping, and on the with vault jumping, pole jumping, yes, and using the pole, and things of this nature. And actually we can connect all the data in terms of the sets, clusters, actually clusters, and the data that is not super usually occurred in our life. For example, it could be falling. If it is not super if it is a rare event, then it will be the falling. Okay, if it will be the event of, for example, yes, falling, or maybe some meteorites or things of this nature will fall, or maybe something super rare, or maybe your shoes could be untied, or maybe your shoes could be torn apart. It is a rare event that we sometimes could consider that not really valuable for us. We will delete it, and actually, yes, it could be. Also, sometimes could be rare events that data is not fixed. Sometimes it is rare, sometimes it is not super rare event. In terms of the percentage of the main data, what we will consider as the rare event. Rare event, maybe it could be 0.05 of 100%. Yes, for example, we have 100.0, and everything that is lower than 0.05, it is 0.005. It will be considered as the rare event from the 100.0, 100.000, if we will be more accurate to it. Okay, it is all about our things, and I will continue to write my PhD thesis, by the way, everybody, and I do writing nicely. And enjoy your day, improve daily, go forward, everything depends only on you, you're a nice guy, or girl. It's the English video, because previously I was uploading a lot of Chinese videos in Chinese language. Let me know, did you understand me, because we have different types of viewers, because I upload to different types of platforms my videos, and did you understand me? Have you understood me? This type of things, do you learn English, or are you a native, or maybe it is your second language as the kind of mother tongue, but second language you learned it from the beginning of your life. And see you next time. Improve daily, you're a nice guy or girl, you can do anything in your life, you're successful, you are beautiful, you are nice, and go forward, find the fruitful solutions to your tasks, write your PhD thesis if you are a PhD student, and improve daily, go forward, everything depends only on you in your life. Have a good day, see ya.